Hello, hi, hello everyone. Thanks for joining for part two of the Subgrounds workshop. I'm Tachi from Playgrounds and really excited to continue this series. This series will be focused on the continuation of the presentation given by Stouffer last week, where we jumped into the anatomy of making queries using subgrounds, and we dove right into uh, what subgrounds is, how to use it, and how it can enable you to perform powerful data analytics on data indexed by the graph. And today we'll be working on the visualization and empowering you with the tools and skill sets needed to take subgrounds visualization components and build not only powerful visuals but web apps as well. So let's jump right into my screen here. Share my screen and move on to here. Let's do this. Awesome. So, a quick recap Playgrounds. We are a team of data engineers, data scientists, and hobbyists, and we are building tools and advanced on chain tools to help you with your data analytics. We build education environments and simulation hubs as well. But our bread and butter, our focus is building those multi faceted tools to help you with your on chain data analytics. For today's content, we'll be covering a recap on what Stouffer discussed last week, our motivations for creating subgrounds, and of course, a quick recap on Dash and Plotly and why it's important for subgrounds. And then we'll jump right into the visualization discussion and the components embedded in subgrounds itself, the anatomy of subgrounds powered Dash apps, and of course, the fun part and why we're all here, it's to build on the fly and see how you can build a data driven app in under an hour, possibly. So, the motivation for building subgrounds is quite simple. We're leveraging the graph because it has a pretty large ocean of pre modeled data, which we call subgraphs. And of course, anyone who's really into the Python world knows it's one of the best tools for data analytics and data science. So we're leveraging that, and that's why Subgrounds itself is purely Python and allows you to not really leave the environment you're comfortable with if you want to perform on-chain data analytics. And our vision is to bridge over the Web 2 data science stack into Web 3. So things that you're already familiar with, just being present and available for Web 3 work as well. And this, we believe, will empower you, the data scientists, the data analysts, the engineers, the hobbyists, to have access to advanced and familiar tools for your on chain data analytics. We talked about this last week. So today we'll be focusing on the center there where we talked about subgrounds visualization components. So that's the focus for this workshop. How do you build visualizations using the Plotly wrappers that are built into subgrounds to create powerful dashboards for your analytics workflow? As a recap, last week we covered subgrounds pretty in depth. We talked about field paths, synthetic fields, and how all of the underlying layers of subgrounds interact with the graph via the subgraphs, and how you can perform transformations and modeling using subgrounds. And again, subgrounds being built for Python developers, so using a language that's really easy for you to pick up, or if you're already familiar with, to jump in. If you want to get a recap on the subgrounds part one, I would suggest going down to the Git book that's provided by MetricsDAO. Thank you very much, MetricsDAO team. And the videos and the presentation slides are embedded in that book as well, if you would like to start with part one before proceeding with part two. So let's jump in, Dash and subgrounds. So first of all, why did we choose Dash as the library to embed into subgrounds? Well, the first is Dash is a low-code framework for building data-driven applications in pure Python. Again, we're focusing on simplicity, a language that's easy to use, and Python is just that. Dash is written on top of Plotly JS and React, so the apps you build will look familiar and for especially for front-end devs. They don't have to learn new tools. Data analysts don't have to learn front-end development to use Dash. It's quite out the box. Dash is also simple to use, and it abstracts away all of the technical skills and tools required to build a full stack web app. You just bring in your data analytics skills, add a little bit of Dash to it, and you're up and running. Your apps are rendered in a web browser, which means it's shareable, it's cross-platform, and of course it works on mobile. So now we're really crossing that bridge into owning your work, owning your analytics work, owning the insight that you generate, and sharing that, and building your portfolio as you move on. And of course, Dash is open source, so that made it really easy for us to to build into a Subgrounds repo as well. So Subgrounds visualization. Subgrounds itself provides wrappers for the Plotly object and Dash components, which is how we're able to facilitate visualization in Subgrounds. And the wrappers themselves can be found in the Plotly wrapper submodule for Subgrounds. And there's no significant change in the behavior of Dash itself. So the wrapper accepts the same arguments you will in a regular Dash app, with the addition of the Subgrounds unique field path objects that are now also acceptable because it's built in the wrapper. So a top level view of what your workflow would look like when building a visualization of your data that you've pulled into Subgrounds. You start with the usual, you import your library, then you construct your query. Well, what are you trying to query from the blockchain via the subgraph and the graph? And then your app construction layer is equivalent to saying your dashboard construction. So in your dashboard, you're able to instantiate the interface between subgrounds, call the query that you've created in the subgrounds construction layer. And once that's done, you have your dashboard rendered. So this is the simplest way to build visualization with subgrounds. Here's what it could look like from a code perspective. You import the library, really simple. You say from subgrounds, I would like my data to be presented in a bar graph and a figure chart. You have that there. And I would also like to call in the graph component. And then your subgrounds query construction layer, it's, okay, subgrounds, I would like to tap into the Aave subgraph. And I only care about the borrows and the repayments, at least the first 100 rows for each of those. So you construct that query. And again, going into the deep dive of that, we covered that in part 1 of the series. And then the visualization construction is, all right, I have my library, I have my query constructed, I would like to plot this. In this case, you simply instantiate the app in the layout configuration, create this is a simple example of just using simple HTML. So HTML div, put a title on there. And as you can see in the code there, we have subgrounds graph dash components. This is where we call in the subgrounds visualization. And we say, all right, for traces, I would like a bar graph where the x-axis is the borrow results from, again, our subgrounds query, the borrow results, and the y are the amounts. And you can do the same for repay in the next line. The x-axis would be the repay that reserve the symbol, so that pulls in the reserve and the repay query, and the y-axis will be the repayment amount. And once that's done, you run the app and you have a visualization dashboard on the bottom there that shows the blue being the borrows and the red being the repayments. That's how simple it is to plot and use visualization with subgrounds. But of course, we can't stop there. We take it a little bit further. How can we take that and build apps with web apps with subgrounds? Because we're leveraging the Dash and we're leveraging the graph. So we can definitely build live web apps that you can share with your friends and your colleagues. This is the architecture that we're looking at here. So from bottom to the top, you have multiple chains and networks that the graph indexes the data on. So you have the network level, the data is raw, it's opaque, and the graph basically just indexes all of that data and organizes them. Then we have the subgraph layer. This is another way of saying the modeled or the pre-modeled layer. This is where the subgraphs represents the data or the behavior from protocols of interest that's been indexed by the graph. And then we have the subgrounds layer itself, which is a tool we've built for you. And in this case, Subgrounds plays the role of interacting with the subgraphs and allowing you to create transformations, interoperate with data from multiple chains, interoperate with data from multiple subgraphs, build your visualizations, or in some cases, just a flattened data table. And the app construction layer is where you throw in the results from your subgrounds and create the dashboards, and they're all embedded in an app container, which then lives on the web. So the subgrounds layer revisited in the context of building an app with subgrounds. Similar to what I showed you in the visualization, it's import your libraries, create your synthetic fields, and create your query. The synthetic fields, again, are just fields that may not necessarily exist on the subgraphs itself. So you use the synthetic fields to create new fields or new entities that are themselves queryable once they've been built. And the subgrounds query construction layer allows you to create the type of queries that you want to request on the subgraph layer itself. In this case, the example shows that there are two types of queries that we want. The first query being we only want 1 year's worth of data, and the second being we want the latest data point available. Now comes the app construction layer. Similar to the subgrounds layer, it's been broken into something simple. You import your library. In this case, you're importing Dash, the Dash bootstrap, to make your app look nice. Plotly, of course. Millify is another tool we use to make numbers look really clean. Subgrounds, of course. And if you notice on the last line there, we have import, and we have, in this example, we created the Olympus subgrounds. And from there, we're importing SG, protocol metrics 1, last metric, proposed and immediate. What do those mean? Well, going back to the previous file, you see that we had created the query types, last metric, and protocol metrics 1 year. This is what we're importing into our app. When we do the import from Olympus subgrounds, import SG, protocol metrics 1 year, last metrics, these are all types of queries that were created in the subgrounds layer, and we're pulling those into the app so we can make the queries within the apps themselves. And of course, the dashboard construction layer is broken into something that's simple. Using the grid system, you're able to place your queries and the outputs in a grid-like structure, so rows and columns. In this example, we're just showing you a single column that is embedded with a card, and in that card, we are pulling the latest market cap for Olympus, and we're plotting a chart using the visualization component of subgrounds, a scatter plot for the own market cap. And the x-axis itself is using the query that we created in subgrounds, the subground layer. It's the x-axis is protocol metrics 1 year dot date time. So we're telling subgrounds, hey, we need the date time for the last year. And then the y-axis is the market cap. So protocol metrics 1 year dot market cap. So what's really going on is subgrounds receives this request from the subgrounds layer we've created, and then pulls the first 365 rows. Each row represents a day for the specific entity or field that you've called. So there is no stored data anywhere in your app. The data is coming directly from the subgraph, which is coming from the graph itself. So this is really powerful, which means you can mix and match, and you can play around and write lightweight code or apps where you don't have to store data anywhere. It's just pulling directly from the blockchain. This is what Subgrounds allows you to do in building apps. And once that's done, render the app and run it, and you can pull it up on your browser. These resources will be available to you if you want to dive into Dash a little bit more and see what you can build. And of course, the Subgrounds library and more documentation of the graph. So let's have some fun. Today, we'll be building a visualization of the KlimaDAO subgraph and trying to see what's going on in the protocols there. I've pre-created a Jupyter notebook for us just to save time. And I've pre-labeled each cell with the logical flow that any analyst would follow when creating an app or visualization with subgrounds. So let's get started. The first part we need to do is import our libraries so we can interface subgrounds with the subgraphs. For that, I like to start with datetime. So I was import from datetime, import datetime. That allows me to work with time series a little bit better. Then I would import subgrounds, subgraph, and import the synthetic fields. This allows me to create synthetic fields as well. Let's see, field paths as well. And again, if you want a review on what synthetic fields are and field paths, please refer to the last week's workshop. Let's do subgrounds.subgrounds instead. All right, so now we have our library. Run that. All good. All right, the next step is to instantiate subgrounds. We've pulled in the library. Let's call it SG. SG is equals to subgrounds. Close that. And like I said, I've already pre-filled some of these. So in this example, I am connecting to the klimaDAO subgraph. So I would uncomment this. And what I'm doing here is I am loading the API for the klimaDAO subgraph on the graph network into subgrounds. So I'm saying subgrounds.load subgraph with the argument being the API URL in there. And this line is done. Pardon me. The next section is to go ahead and start constructing some synthetic fields. One thing we notice about a lot of subgraphs is timestamps are not necessarily in a format that we can understand. So I like to create synthetic fields for datetime and just transform the normal timestamps into something that we can understand as humans and read. So I'm just going to create a quick Lambda function. And just say the increment argument, and I want to format it. Let's say format. Yeah, let's do the timestamps. Yeah, let's just do from timestamp. And timestamp. And that's going to be a synthetic field and string. And let's say that's for the klimaDAO protocol. Dot timestamp. And that should be it. That's that synthetic field for the timestamp. And let's go ahead and run this and make sure I didn't goof here. Protocol metrics. Metric, klimaDAO. There it is. There's no plural, it's singular. Awesome. And then let's create another one. For klimaDAO, something that people really like to see is the ratio of staked klima versus unstaked klima. But since that's not necessarily a raw or readily available metric on the subgraph, we have to create this metric using the synthetic field. So to do that, let's create another synthetic field, and we'll call it protocol metrics. And we're going to create this field from the staked. So let's do that. Let's call it staked supply percent. So we're saying, all right, I want to create a synthetic field called staked supply percent. And I want to do this. Again, another simple Lambda function here as klima supply. So now the input argument for this are sklima supply, which is available on the subgraph itself, and total supply. And that we just do multiply 100 by sklima supply divided by total supply. And this should give us the staked supply percentage. What else do we want to add? Okay, let's go ahead and do a total supply. Synthetic field. Right. And let's add. Let's see what's going on here. Gotcha. We don't do duplicates here. Put a comma, synthetic field, and let's put in the lists. KlimaDAO.protocol metrics. S klima, in this case, klima circulating supply. And let's do the same here, klimaDAO.protocol metrics. Total supply. And so we've created this, but what happens if there's, let's create a default. So let's just say the default for this synthetic field, when there's nothing there, we just say 100. So 100% is staked. That's usually not the case, but that's a good default to set there. And so now we have that. And here's something cool that we can do. We've created a synthetic field called staked supply percent. Now we can create another field using this synthetic field. Let's call that unstaked supply. So in that case, we'll just simply do something like, and here's where the power of synthetic fields comes in. So we'll say metrics dot unstaked supply percent is equal to, and in this case, we'll just say it's 100 minus the variable we just created earlier on. Sorry for the noise. I live in a pretty noisy neighborhood. All right. So we've created a new field called unstake supply percent, and it's simply just 100 minus whatever the synthetic field generates to populate this new variable we've created. So it's pretty simple to create synthetic fields and start operating on them immediately. Another thing that's really cool about klimaDAO is the treasury. So let's go ahead and create a new synthetic field. And maybe this would be the last one, so we can keep it nice and simple, nice and clean. Let's say metric dot, and to do that, we just say, all right, cool. What's the RFV per Klima? We know that Klima accepts tokens to back, or accepts carbon to back their token. So in this case, let's find out what the risk-free value is. So in this case, it would be RFV is the treasury and the total supply. In this case, it's a treasury RFV divided by the total supply. And let's just add some logic and say, like, if the treasury RFV divided by the total supply, otherwise, there's no backing. And let's create a synthetic field, dot floats, create some formatting there. And in this case, we'll say klimaDAO dot protocol dot treasury risk-free value. See, I think I had a spelling error. There we go. And do the same thing that we did there, but for total supply. All right. So let's go ahead and run this as well. Let me make sure I never just realized I've not been checking. Let's see. There we go. Awesome. We are good. We have constructed our synthetic fields for timestamp, synthetic field for staked supply percentage, which allowed us to derive the unstaked percentage, and a synthetic field for the RAV par klima using entities that existed on the subgraphs themselves. So now let's go ahead and construct our queries. In this case, let's say, all right, well, we want to pull in data from the last year. So what does that mean? And we also want to pull in the the latest data. Go ahead and do that. Let's create a function. I'm just going to do a simple make request. All of these documentations are available on the GitHub repo. If you have more questions, please go ahead and ask in the chat as well. And Stouffer is manning the stations. I can't see the chat right now because I am trying to type code as I go, but I trust that Stouffer has it handled. All right. So now we're creating a function that we just pull in the latest data. And let's go ahead and create a query type for the last year's worth of data. So in this case, we're saying protocols metrics 1 year equals to klimaDAO dot query dot protocol metrics. Oops. And let's make sure it's all right. Protocol metrics 1 year. Yep. And then we'll do an order by. Let's order the data by timestamp. So let's say I want to order this query. So what I'm telling Subgrounds now is when you make a query, the data that's returned to you, order that using the timestamp field. So we do that using metrics timestamp. And I also want to order the direction of it. In this case, I want the direction to be descending. What else is important for us? Oh, it's a year. So just give us the first 365 days worth of data. So now we've constructed a query that when Subgrounds request data from Subgraph, it's going to, first of all, only pull the first 365 rows. It's going to order them by timestamp in descending order. Another thing we can do is, that's also very similar to immediate, is you can just explicitly define a query that pulls in just a single data point from the rows. And then from that rows, you can say, just give me the latest row. So say klimaDAO query matrix, open that up. And I'm just going to, just be efficient here. Copy paste. So it's you. There we go. Instead of 365, I do 1. And that's it. That's the second query. So now we have a query that gives us a year's worth of data and the latest data point. We have our synthetic fields, and I think this section is good to go. So let me go ahead and run this. Let's see. Protocol metrics. Okay, let's jump in. So, quick recap. We imported a library. We said, hey, we want to use Subgrounds. I want Subgrounds to interface with the API. And I know there's some fields that metrics that don't exist on the subgraph. But hey, Subgrounds has synthetic fields. Let's create them. Let's create some transformations using the synthetic fields. And now let's define the types of queries we want. But let's not stop there. Let's build some visualizations. So the first step in doing that, as we've outlined here, is to call in dash. So let's go ahead and summon dash. And so we have dash core. Then usually I like to make my dash app look really nice. So I use Bootstrap. That's another powerful thing with dash is it comes with Bootstrap built in. Dash Bootstrap components. And I say from dash, I would like to import the HTML component so I can structure my app better. And from subgrounds dot dash wrappers, I want to import graph. And from subgrounds as well, in this case, I want to go into the Plotly wrapper module itself. I want to import three things. I want to import figure. I also want to import scatter, bar. I'm not going to use most of these, but just to show you how you can connect to the natural visualization components in Plotly. So we have that. And some numbers might look really long. You know, you're dealing with floats. So let's use Millify to create like nice shorthand for longer numbers. Things like, like 6 billion could be shortened to like 6B, for instance. That's what Millify does. Something that's interesting is we're using a Jupyter Notebook for this demo. So this is an add-on just to make life easy for us. So I'm just going to do from Jupyter Dash. This is not part of the normal workflow, but if you're using Jupyter Notebook for your app or visualization development, it's really nice to have Jupyter Dash. This allows you to render your visualization in line with the cell blocks, just FYI. And now let's construct a dashboard. To do that, I would like to take a moment to kind of go back to this viz here. What we're doing is something similar to this. We are going to create an app container, very easy. And in that container, we're going to create blocks. The blocks are grids. So we have rows, and in those rows, we have columns. And you can have infinite number of rows and columns. As big as the app you want to build, you can do it as long as you follow the grid structure. So let's correlate the app container back to the code. So when I say app container, what does that mean? Well, it just goes here and say app.layout is equals to html.div. In this case, the div is the container itself, right? Normally, you would have something like dash.container, but we're making this demo really easy for us, so we're just going to use an HTML div. I forgot to put this, Jupyter dash. This helps us create an instance of our visualization. I think I did that right, yep. And let's go ahead and throw some code in there and see what it gives us. The first thing I want to do is create a quick little topic here and just say this division or this dashboard is just going to be for market cap. And the next thing I want to do is create another div. And in there, I want to call in the graph component and do the figure. And now we're in it now. So let's say subgrounds is equals to SG. And I want subgrounds to create traces for me. And these traces are just going to be scatter. Let's just do scatter. Scatter always looks nice. And for scatter, we're just going to have name is equal to, let's call this chart market cap. Paste there. And the x-axis is going to be protocol metrics for the year date time. So we're saying call the date time, which remembered wasn't even a metric to begin with in the subgraph, but we created it with synthetic field. So what's really happened is when we say query datetime, it's actually querying timestamp and formatting it into a datetime format. So we say, all right, x-axis for the last year, datetime. Then we say the y-axis is protocol metrics for the year dot market cap. And let's just create a stack view for it. Not necessary, but one. And what else can we add to this? Hmm, I think this is a good place to stop for this particular one. So let's go ahead and do an app.run. This goes back to the rendering of our dashboard. So the mode is equals to inline indoor ports is equals to, I'll just say 8090. I think that's available in my system. These are just standard configurations that will provide details in the documentation after this. And I think let's do a hot reload so it updates if we make any changes. And let's say true. Threaded. And let's make that true as well. Okay, that's it. That's our visualization. And let's go back to here so we kind of review what we just created. We started with subgrounds in the Jupyter notebooks. We imported everything we wanted. Then we created the library, imported them, created a construction of the dashboard, and now we are rendering the dashboard. So let's go ahead and run this. Let's see where I stopped. All right, that's good. If I run this and I haven't goofed, it should query it. So it's querying the blockchain right now. And in any moment, we should have a rendering of our chart. Let's see. Let's give it a moment. All right. It's still loading up. Let's see. Okay. I'm already using that for that. That's okay. Let's do it again. There it is. Awesome. So now we have rendered a visualization of the market cap plot using subgrounds and the plotly wrappers within subgrounds. Really easy. Took us less than 20 minutes to do this. But let's not stop there. We're having fun. Let's show you how to then take what we've learned here and build a web app with it. And the steps are not that different. So what I've done here is I've pre-created the files for expediency. The files I've created are reflective of what we've done here. So we'll create one file to represent the subgrounds layer, and the subgrounds layer would just contain the subgrounds code itself. And we've created another file for the app construction layer, and that will contain the dashboard creation that we've done. So really, we're just going to break apart what we've done in this notebook into two distinct files and connect them to each other. That's what we're doing. So we have the subgrounds layer. In the subgrounds layer, I have simply copied and pasted everything we wrote here, minus the comments, of course, into its own file. We can see a one-to-one match all the way to last metric for subgrounds. And then for the dashboard itself, I will jump in here and rewrite this so we can see how that's built. But before moving on, do we have any questions? Does anyone have any thoughts, concerns? Would you like me to revisit any particular topic I just covered before moving on? problem. So let's be efficient here. So I'm going to copy the libraries that we're going to need from the demo file, just so we move at the speed of light. So we're just importing the libraries as I showed you here. Boom. And we need the dash, bootstrap, HTML, Milify. We need the subgrounds wrappers themselves. And of course, the queries that we made for the year, the last metric, and immediate. And now let's go ahead and create our file. So in this case, we say app is equals to dash dot dash, and it's going to be name. And let's just, we don't want that. We want style sheet. Go. And in that one, we want to use Slate. I will post a library of Bootstrap themes to allow you to make your dashboard look nice and sleek after this presentation. So now we've created an instance for the app itself. And going back to our grid system, let me recall that back here. We're going to create an app container. And in that app container, we're going to have 4 rows for this demo. And this is the final product, by the way. The app container is going to have 4 rows. The first row will be protocol metrics demo, row 1. The second row would be the smaller cards, each having columns, 1 column for market cap, Klima price, current APY, and total value deposited. The third row would be for the charts, and then the fourth row for the charts as well. So sneak peek on what we're building. So let's go ahead and build it. So of course, we start with our app layout. We're creating that very first container. In this case, we say dbc.container. And now we just put our data in there. It's that easy. It's really fun and easy to do this. We say the first row, we want to just have a simple column, dbc.call. And I am coming close to the hour, so I will try to move as fast as I can. And I'm going to create a label here and just call it, protocol exploration demo. And let's go ahead and just close that. And let's create a new row. And in this second row, we're just going to create a column. And in that column, we're just going to have some cards. Again, we're trying to create these individual cards. So let's say dbc.card. Documentations will be provided, I promise, on what a card means. dbc card body. And in that card, I want to have a simple label that says market cap. And let's do that. HTML 1. And in this case, I want to, let's just put the latest market cap value in there. So to do that, let's do like a $sign. And let's do some string concatenation and use Milify to make our numbers look pretty, because the market cap can sometimes occupy too much space on our screen. So I'm going to use last metric. So this is the beauty, like we're not storing the data anywhere. We're querying the blockchain and passing the results into our card. And let's do a precision of 2. And here, something, I think it's maybe the last metric dot market cap. See, Okay. Ah. Here. What is it screaming at? See what I did here. Let's accelerate this programming session and show you line by line what's going on here. Okay, cool. So in this example, we have created a row and we've created a card. And in that card, we have the body that has the market cap as a title. And we are pulling the last data point for market cap. And then we are creating another column, this second column here. And for that column, we are calling the Klima price, and we're repeating the same thing that we've done here, and except replacing market cap with Klima price, and doing the same thing over and over again for current APY and TVD, total value locked. And that's the code, simple code required to create this first row where the values are live updated from data on the blockchain pulled by the subgraph itself. So now that that's done, the same thing is done for the second row. In the second row, we have dbc.row, and in that, we're creating a column. One moment, please. Let me. Here. Right. We have the second row. And in the second row, we have the cards like we've done up here. And we have the labels for the Klima market cap. And what's different here is similar to what we did in the notebook. The card body, we're calling the subgraph graph component. And we are doing the X and Y components for date time, and the Y component being market cap. And you would notice these are standard dash styling syntax. So simple things like show legend, x-axis, line colors, the grid, the background color for the paper, the background color for the plot itself, how tall we want the graph to look. These are standard syntax in Dash that allows you to style your charts. So what I've done here, or pre-done here before this demo, was create multiple charts for the state Klima using the queries that we created in the subgrounds file itself, which can be found here, last metrics and protocol metrics. And we are just basically playing around with the charts. So we have scatter charts for the staked supply. We're stacking that on top of the unstaked supply with creating the syntax for the layout and creating a new row. So that's our row 3 when you come here within the container. And in there, we're also just pulling the RFV per Klima and the Klima price and styling them. So after a while, you end up just copying and pasting the layout code once you have the first format done. So you say, oh, okay, this is pretty repeatable. I'll just copy this entire row as done here. And I'll just replace the X and Y components with the variables that I want to show to my community. Price RFV ratio, in this example, Klima price. And you just do that as many times as you want. And once you're done, your app is essentially built. And to render this in your browser, so let me go ahead and close this demo, and I'll figure out what the error I was receiving earlier is after, and I'll show you what it takes to go ahead and run an app. Once that's done, to render your app in your local browser, so let me go ahead and close this, close that file. and go back to the code. We do pipenv run. So we're saying, hey, create an environment. I want you to run Python. And you just call in the name of the file you have. In this case, it's Klima Analytics dashboard.py. Make sure I spelled it right. Yep. And you hit enter. And your environment, your pipenv, basically just takes in all of the components you've built, the libraries that you've imported, it installs them. And on the back end, what Dash is now doing is it's handling all of the full stack expertise that you would need to build the app and just giving you a simple link. In this case, it's running locally on my system. So it's just telling me, hey, your app has been rendered, everything's ready to go. Just visit this link locally, of course, on your PC, and you get to see the app running. So what I simply have to do is go back to Chrome or any of my preferred browser, and I type in 1.125. There it is, and my app is fully rendered. And each time it updates on the blockchain, any data that's changed is automatically updated as well on the cards itself. And of course, you get the standard run-of-the-mill analytics stuff for charts. You can zoom in, you can interact with the charts, but it doesn't stop there. There's so much you can do with the Plotly visualization library that's now being brought to your fingertips thanks to Subgrounds. So this is a simple demonstration on how you can build visualization within your Jupyter Notebook, as shown here, or taking it the next level and building web apps that you can share with your team or your friends or anyone who might be interested in some data that you've analyzed for a protocol of interest. And that's it, guys. That's the demonstration on visualizations with Subgrounds. Thank you so much for your time. Do you have any questions, comments? Would you like me to revisit anything specifically and go from there?
Well, that looks absolutely awesome to me. Thank you for running through that. Super excited to dive in and try spinning up something of my own. I don't have any questions. Anyone can feel free to come off of mute or post in the workshops channel. I'll give you a second there.
Thank you. See, let me scroll through the channel, the workshop chat, and see if there's any questions. Oh, I see Stouffer has been manning the stations. Thank you, Stouffer. Let's see. Okay. Okay, so it looks like there's no specific questions to what was covered. Thank you so much, everyone. As I said, I'll be providing you with more documentation on Dash. It should already be in the Git book. And several more examples on dashboards that you can build. I have some Olympus dashboards that we've built, some wallet tracking, wallet activity and wallet tracking dashboards that we've built as ways to test the visualization for Subgrounds. And those will be tools and examples that we'll be happy to provide to you within the next day or so you can have a vast library of examples and get your visualization and analytics journey started with Subgrounds. Thank you all, everyone.
Awesome. Thank you so much, Pachi, and we'll look forward to seeing you next week for part 3.
Yes, sir. Have a wonderful day, everyone. See you next week.
Bye.